A very good evening. Today we're going to explain about Lab 5, which is RC and RL high pass filter. First and foremost, we would like to introduce ourselves. I'm Sarvina.
I'm Yamunaa Mahadevan.
I am Izzan Hazira.
As you can see in this lab, the first circuit is about RC high pass filter. This is the circuit that given in this lab sheet.
Okay, so a high-pass RF filter is a filter which passes through high-frequency signal composed of a resistor and a capacitor. So to create a high-pass RC filter, the capacitor is placed in series with the power signal entering the circuit, such as shown in the circuit below here. Okay. So to find the TF, the transfer function, we must first find the impedance, which is Z equals to 1 over RC. And then we can include the Z inside the TF formula to get the answer by using the complex mode in the calculator.
Okay, now we can move on to multisim. We're going to construct this circuit using multisim software. And first you need a capacitor. So you can find the capacitor in basic. So the value given is 470 nano. You can place it here. After that, resistor. And then ground. Oscilloscope and also function generator. Okay, now I'm going to connect all the components together. Channel A goes to the resistor and channel B goes to the resistor. And function generator, we can change it to 100 as given in the table in the lab sheet, and amplitude is 2 BP. And this is how we will get the value, the waveform for this circuit. We can change the value of scale over here. So this is how we got. So to find the value of peak, we must place the channel A and channel B here.
Okay. As a capacitor is a reactive device, it offers differing resistance to signals of different frequencies entering through it. A capacitor is a reactive device which offers very high resistance to low frequency or DC signals. As it offers very high resistance to DC signals, it blocks them from entering though. So as you can see in the circuit here, so this type of filter only allows high frequency signals to pass through and not DC. This type of capacitor also functions as a coupling capacitor because it couples the AC signal from one part of a circuit to another while blocking the DC signal.
Okay, from this oscilloscope, we can find the value of T2 minus T1 and the value of channel B. So in this graph, in this lab sheet, so here you can see the value of frequency, and V out is what we get from channel B over here, and then you can change the value of frequency as the table given, like from 100 Hz to 10 kilohertz. For example, you can do for 200 Hz. So you must change the value of frequency here, and then just start the stimulation. So you can change the value of scale as you want. So this is how you'll get the waveform. So once you pause, you can move your channel A and channel B to the peak value. So this is how you will get the value of time and the value of channel B. So as given in this graph, in this table, this is frequency. V out is what we'll get from the channel B, and AV is equals to V out and divide V in, which is divide 2, and then AV is it's given here. AVDV is 20 log divide AV. Times AV. So it's given in this lab sheet. So we can use this formula to find AVDV. Okay, next you can see for RL high pass filter. Okay, this is the circuit that given for RL high pass filter.
A high-pass RL filter is a filter composed of a resistor and inductor which passes through high-frequency signals. To build a high-pass RL filter, the inductor is placed in parallel to the power source signals entering the circuit, as shown below. And in order to find the transfer function, we need to use the equation as shown there. Impedance equals to 1 over L over R. And after that, we can include the value in the TF equation.
Okay, for RL, we can use the same circuit, but you can replace the component. For just now we use capacitor, so now we can change it to resistor. So this one we can replace to inductor. So this is the circuit. So for function generator, like just now, we can change it to 100 Hz and amplitude is 2 dp. And this one, we can change the scale to find the waveform. Okay, this is how we got the waveform. So to find the value of time, we can move the channel A and channel B to the peak value. So we can even adjust over here. So this one we can adjust here, and this is how we will get T2 minus T1, and we will get the value of channel B. So
it passes through high frequency signals. An inductor, like a capacitor, is a reactive device. Inductor offer different resistance to signal input into them of different frequencies. Inductor pass low frequency signals with very little resistance, while offering great resistance to signals of high frequencies. Thus, low frequency signals pass through very easily without any attenuation, and high frequency signals are either completely blocked or greatly attenuated as output.
So we can see in the table in this lab sheet for RL. So same like just now, the frequency given from 100 Hz to 10 kilohertz, and V out where we'll get at channel B, and then AV equals to V out divide V in, which is V out. This value divide 2 will get the value of AV, and AVDV is given in this lab sheet 20 log divide times V out divide V in, which is AV 20 log times AV. So we can use this table to find the answer for AV and DV. And then you can see here, this is the calculation that we got for this lab. And then this is the stimulation that we did for RC high pass filter stimulation. And then from 100 Hz to 10 kilohertz. After that, this is RL high pass filter from 100 Hz to 10 kilohertz. That's all from us. Thank you.
Thank you.
Thank you.